We now move to loops, starting with the while loop. In the loops lies the real beauty and usefulness of programming. Here, the problem is to quickly write integer numbers from 0 to 100 to the terminal.
I begin by including the IOStream library, and I declare an integer x with an initial value of 0.
Inside the main function, I use a while loop with the condition x less than 101. On each iteration, the program prints the current value of x followed by a semicolon, and then increments x by 1. The looping continues until the condition is met. So the x variable starts at 0, and the loop continues to execute until x reaches the number 100.
If we remove the x increment statement, we would create an infinite loop. Infinite loops fill a computer's memory, and it crashes the program.
This way, numbers from 0 up to 100 are printed. I can change the condition to x less than or equal to 100. I can also extend the loop to handle the number 100 properly by combining the while loop with the if statement. When x equals 100, the program prints the number with a period at the end. Otherwise, it prints the number with a semicolon. This small change improves the output formatting. Next, I rewrite the program using a for loop instead of a while loop. The for loop is the most common loop that you'll run into when you code. Again, the goal is to quickly print the numbers from 0 to 100. The for loop initializes x and runs as long as x is less than 101, incrementing x by 1 on each iteration. Inside the loop, I simply print the current value of x, followed by a period. For loops have an incrementing value in the condition statement, so it's much less likely that you'll cause an infinite loop when you use them. So, compared to the while loop, a for loop has a breakdown procedure built in. Note that the counting variable x is not incremented on the first loop. Only on the second loop is the x variable incremented. I can also combine the for loop with the if statements. If x is equal to 100, the number is printed with a period at the end. Otherwise, the number is printed with a semicolon. This makes the output look consistent and clear. Finally, here is an exercise to print a rectangular shape in the terminal. I include the IOStream library and declare two variables, I_row and I_call, which will serve as loop indices. I also define two constants, width set to 10 and height set to 5. Inside the main function, I use a nested loop. The outer loop goes through each row, while the inner loop goes through each column in the row. For every column, the program prints a star character. After finishing a row, the program outputs a new line moving down to the next row. The result is a 10 by 5 rectangle filled with stars.
Don't forget to like, comment, and subscribe for more videos.
An advantage of using variables is that in the end, I can quickly change the number of columns and rows and print a different rectangle without the need to rewrite the program. It's important to design your code well and use the most efficient structure that makes the code easy to read if you ever need to change it.